All right, unofficial advent of code day 17. Here we go. You finally decode the elf's message. Hi, the message says, searching for sleigh keys, large ocean trench. Could the keys have fallen into it? You better send a probe to investigate. Probe launcher on your submarine can fire the probe with any integer velocity in x, y, in the x forward and y upward direction. Probes x, y by moving in steps. Whoa. Input equals stirs dot split equals let's see, empty x y xmin equals x's dot split map to I. What's xmin x max? Two 6. Okay, perfect. X equals 0, y equals 0. All right. This target area means that you need to find the position how high can you make the target probe go while still reaching the target area? Okay. Init y equals 1. Max h equals 0. Okay. Loop 2. Init vy equals 1. Init vy while init vy is less than equal to y max. Oh, init vx. Init vx plus equals 1. Init Okay, init vy equals 1. Loop do init vy plus equals 1. Def shoot vx vy. X equals 0, y equals 0. Okay. While y is while x is less than x, loop. Yeah, I need to get a separate arm or mount it not on my desk. All right, x plus equals vx, y plus equals vy. Vx minus equals 1 if vx not equals 0. Vy minus equals 1. Okay. So we're basically going to shoot it 1 to the right. And then okay. If Vx so if Vx equals 0 and Vy and y is less than x is less than x min, between short. Okay. So it has to go at least 206, which is square root 206, 14 times 15 over 2. Okay, so insufficient x vx. Okay, if x is greater than x max and y is greater than y min, return to high, return to low if x is greater than return to low if x is greater than equal to x min and y is less than y max. I appreciate the help, but I'm trying to do this myself. And I'm realizing that my x min and max are switched, or my y max and min are switched. I think input y, okay, this is y min, y max. Okay, so this should end y max min. If x min x and x min return hit if and x is less than equal to x max. And y min is less than equal to y and y max. What if x is greater than x max? Miss. Okay. Puts trying init velocity init vx init vy result equals shoot nil max y equals 0. Max y equals y. Max y. Equals shoot init vx init vy. Max height. H equals max h max height max if max height. And max height is greater than max h. Puts incrementing dx. Put new max height. Insufficient Vx. Okay, so we break if result equals insufficient Vx, break if too high. Too low. I don't want to do this, but trying to init velocity 21.2, hit 3. False. Puts xy equals y if log if res equals to hit. Oh, I guess that's not necessary. Shoot init vx init vy log true. Oh. puts max h. Now okay, I think my too low calculation is messed up. Too low if x is greater than x max. Break if result equals too low and init UI is greater than. Let's try this. See. Oh goodness. Okay, cool. Num hits equals 0. Num hits plus equals 1 if equals hit. Num hits. VY, I think I want to try lower VYs. Yeah. Y min. Too low. Okay. But if I get rid of this, it infinite loops. Regional upper bound, I'm not sure. But this, oh, okay, I did this. I did update this. Y min. Or no, Y max. No, y min. When is it too low? Okay, so if velocity x is 0 and we're not there yet, then we are insufficient vertical vx. Otherwise, if we're too high, if we get past x max, we're too high if y is greater than y max. If x equals x min, let's see, does this work? No. Oh, yeah, this should be greater than equal. Let's see. First far enough equals false if x is greater than equal to x min. First equals true if first far enough and y is less than y min, turn to low, nil, miss, if y is less than y min. Shoot init vx init vy log true exit if init vx equals 20 and init vy is greater than 100. $210. Oh, interesting. Wait, what is 210? Huh. So if it eventually stalls within the target area, then yeah, how can it possibly know there, yeah, there are lots of values it could be. How many times does y equal 0? I don't know if that's relevant. The problem is that if you, with this initial x velocity of 20, it stalls out at within the grid. And so you can try just shooting higher and higher. Is it symmetric? Yes, it is symmetric. Oh, okay. Why is it symmetric? Okay, so if the init Vy is greater than the absolute value, while init Vy.abs is less than or equal to ymax.abs. What happened? I've made a mistake. Oh. There we go. True y max equals y min y max true y max. Three, 5, 7. What? That's what I got before. $101. Why does he have to format it like this? This is insane. There we go. All right, what are the values? 6. Weird. Okay, am I getting a lot of things I shouldn't? Oh, wait, no, never mind. Six 0 through 6 9 7 -1 through 7 9 8 -1 -2 1 9 Am I missing things at the end? Yes. 30 -10. But no, don't even like give any hints. Put true y max. Oops. True y max. Okay, so it starts at -10. -1. There we go. Okay, there we go. Day 17 done. Ugh, that was not very good. Okay, let's go over this problem, which I did definitely not get on the leaderboard for. Does that do it? Cool. All right, let's go over this problem in detail. Day 17, trick shot. You finally decode the elves message. You continue searching for the sleigh keys. Ahead of you is what appears to be a large ocean trench. Could the keys have fallen into it? You better send a probe to investigate. The probe launcher on your submarine can fire the probe with any integer velocity in the x, forward, and y upward directions. For example, an initial xy velocity like 0 through 10, 0, 10 would fire the probe straight up, while an initial velocity like 10, negative 1 would fire the probe forward at a slight downward angle. The probe's xy position starts at 0, 0. Then it will follow some trajectory by moving in steps. So this is what we have here. We're going to shoot in a direction, vx, vy. So we initialize x and y to 0, and then on each iteration, we increase our x and y positions by the x and y velocity, and then due to drag, the probe's x velocity changes by 1 toward the value 0. It can also go from like -5 to -4, but I'm assuming that everything is forward. So we just decrement 1 if it's not equal to 0, and due to gravity, the y velocity decreases by 1. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within the target area after any step. Submarine counter has already calculated the target area, your puzzle input. For example, x equals 20 to 30, y is -10 to -5. This target area means that you need to find initial xy velocity values such that after any step, the probe's x position is at least 20 and at most 30. And the probe's y position is at least -10 and at most -5, whatever. So then it gives some examples. Probe appears to pass through the target area, but it is never, oh, that's still explaining the example above. Basically, you can have things that can like skip past the target area. If you're going to fire a highly scientific probe out of a super cool probe launcher, you might as well do it with style. How high can you make the probe go while still reaching the target area? In the above example, using an initial velocity of 6.9 is the best you can do, causing the probe to reach a maximum y position of 45, which is the highest y position it reaches on this trajectory. So, we basically are going to loop over all possible trajectories. We're going to start with our initial x velocity being 1. And then we're going to start our y velocity at this thing, this negative true I max. I'll get to that in a bit. And then we loop over while it's less than this true y max, whatever. We're going to shoot in that direction. When we shoot, we have something that tells us if it was insufficient x direction, which basically means that our x velocity was too low, that we never even got to the trench. And then also we have too high if basically when it gets to the end of the trench, it's still above the target area. Or when it gets to the end of the target area, it's still too high. So then we can stop increasing Vy and we need to increment Vx again. This will return two things, the result and if it did hit the max height it reached. So if we have a max height and it's greater than our current one, we'll update it. Then we just update Vy, keep updating Vx. So we'll go into these little results things. If the x velocity has zeroed, but we still haven't gotten to the left side of the trench, then insufficient Vx will return. because no matter what v at y is, we'll never get there. If we get past the trench, the target area, and our y is greater than the top of the target area, then we're too high, and so we should stop. But otherwise, if like our y is actually in the middle of it, then we might have just like missed it. So that's a different sort of thing. If we're in the target area, we say we hit. Otherwise, these are two things that I was trying to understand, like if we were too low, but being too low, it doesn't really matter. Basically, because I was having this infinite loop problem that I'll get into. Basically, if we're past the start of the target area, but we're now below the minimum y value, we're not going to hit it, so we can return something. So the problem is you have some velocities, like because the x velocity eventually becomes 0, you have trajectories like this where it goes up and then it starts falling straight down. But in this sort of situation, if you just keep increasing vy, it'll just go higher and then come down again. So like eventually it will, like, you could just keep trying and like hoping that it would go through the points below you. So it's unclear when that it'll stop. But this is a parabola, basically. We have constant, if we look at our y velocity over time t, it's a parabola with constant deceleration of 1. And so it'll be symmetric. And so when we get back to, when the thing gets back to 0, it'll have the initial velocity that it started with. If you're shooting it up, when the thing gets back to 0, it'll have the same y velocity, but in the opposite direction. And so if at that point its y velocity is greater than y min, then it's hopeless. I'm assuming that y min is below you. Some of this code kind of handles like both cases, which is like a little tricky. I don't know if like other inputs would have like y's that, if like the y target area is like -5 to 5. But anyway, if like when you finally get back to 0, your y velocity is like -200 and your target area is like -150 to -100, you're gonna miss it. So basically, like you pick the bottom thing, and if your y velocity is ever greater than that in absolute value, you've gone too far. So that's what this little thing is. I basically like get the biggest y value in terms of absolute value, and then takes the max. And then I set the initial y velocity to negative that, and then while the absolute value is less than the positive value of that, I go through all of those y velocities. Yeah, so that's that. So yeah, in terms of like actually the part 1 bit, it's pretty straightforward to keep track of when we're shooting, the max height that we get to, and when we have a hit, we return that max height. And so we just update the max height here. And then part 2 is you need to find every initial velocity that meets these criteria. How many distinct initial velocities are there? So we just keep track of num hits, and whenever we have a max height, we increment the num hit. And that's all we have to do for part 2. Pretty straightforward. Yeah. So Yeah, that is advent of code day 17.